Hello everyone, today let's take a look at Quantipus number 43, kind of a combinatorics and a conditional probability question where we shuffle a standard 52 card deck and reveal cards one at a time until you see the first ace. And that ace in our situation happens to turn up in position 14, so given that information, what's the probability that the very next card is the King of Hearts? Okay, so let's define some events to make the notation easier. A14 will be the event that the first ace is in position 14, and KH15 will be the event that the 15th card is the King of Hearts. So the question is basically asking us for the probability of KH15 given A14. Okay, so first let's solve the question, and then next I'll explain why the answer is not 1 out of 51 like you might think. So we know what conditional probability means. We take the magnitude of these two events happening simultaneously divided by the magnitude of just the first ace being in position 14. So first off, what are the number of ways that the first ace could come at position 14? Well, basically I want this 14th card over here to be my first ace, keyword first ace, so we do not want any aces in the first 13 cards. Okay, so for my first card, I have 48 non-ace options. For my second card, I have 47. For my third, I have 46, all the way down to my 13th card, for which I will have 36 different options. So we multiply all these together. We'll just write this shorthand as 48 factorial on 35 factorial. Now for my 14th card, which I want to be an ace, I have 4 options, right? Because there are 4 aces remaining, so times 4. And then once I've dealt all those cards, that will be 14 total cards that I've dealt. I'm going to have 38 remaining cards that I can permute in any of 38 factorial ways. So I multiply this by 38 factorial. So this number right here, once I multiply it all out, is the number of permutations of my deck such that the first ace comes up at position 14. So now let's find the number of ways that that happens. And on top of that, also, the next card is the King of Hearts, our 15th card. So we're pretty much going to do the exact same thing here. Now for these first 13 cards, I don't want any aces and I don't want the King of Hearts as well. So that leaves me with 52 minus 5 equals 47 choices for my first card, 46 choices for my second card, 45 for my third, all the way down to my 13th card right here, for which I will have 35 choices. So again, shorthand, I'm just going to write this as 47 factorial divided by 34 factorial. Now I still want my 14th card to be an ace, so I have 4 choices for that. So let's multiply this by 4, and now I also want my 15th card to be the King of Hearts, and there's only one King of Hearts, obviously, so I have one choice over here. Okay, and now I've placed 15 cards, so now I have 37 cards remaining that I can permute in 37 factorial ways. So let's multiply this again by 37 factorial. Obviously, we multiply it by 1, it's going to be the same number. Now up here, this is what we were trying to get, so let's just take this number here and divide it by this one over here. Obviously, first of all, the 4s are going to cancel. And when you work it out, you're going to get this on this, and then you flip it to rearrange this, and then you notice this 34 is going to cancel with the first 34 of this, and we're going to get 35 on the top, and on the bottom, this is going to cancel with the first 47 of this, and this is going to cancel with the first 37 of this, so we're going to get 48 times 38 on the bottom. And that gives us our final answer of 35 on 1824 in its lowest form as well. Now we could have thought about this some other ways as well, obviously. You may have done this with probabilities instead of magnitudes, which also would totally have been valid. If these were probabilities, you would have just taken them over 52 factorial, both of them, and then they would have canceled out anyway, so you would have got the same answer. Another way you could have thought about this is take the probability that there's no King of Hearts in the first 13 cards, given that there's no aces in the first 13 cards. And then you know the 14th card is an ace because that's what you're conditioning on. And then for the 15th card, we will have 38 remaining and only one will be the King of Hearts. So the odds of getting the King of Hearts after the King of Hearts is not in the first 13 cards will be 1 out of 38. And when you do this out, you'd get that this is equal to 35 on 48. And then this right here is 1 on 38. So you'd end up with the exact same answer of 35 on 1824. So now why did we get a number that's slightly less than 1 out of 51? If you calculate this out, you'll get roughly around 1.92%, and if you do this one, it'll be around 1.96%. And the reason this is true is that when we're conditioning on no aces being in the first 13 cards, that makes the probability that the King of Hearts is in the first 13 cards a little bit higher than if we were allowing aces. So the odds that the King of Hearts survives all the way until the 15th position is going to be slightly less. So yeah, again, I thought this problem was pretty cool, so that's why I put it in, and this was our final answer here.